In class today on this problem 4, this is where we had finished, so this is where I will pick up. We had an expression for cost. We used the equation for volume because we knew the volume was 20 pi. We isolated the h and then we plugged that back into the cost formula. So now we have a single variable in our cost equation. So now we're ready to take this derivative and find the solution to the problem. I would simplify this expression a little bit more, so let me do that first. It looks like I'm going to have 20 pi r squared plus, and then 16 times 20, that is 320 pi. The r divided by r squared, that's going to leave me with an r in the denominator, kind of like this, but we've seen in quite a few problems so far just how much better it is to write it in exponential form instead. So I'm just going to say 320 pi times r to the negative 1. So now we're ready to take the derivative. I would say that c prime is 40 pi r minus 320 pi r to the negative 2. We have a few ways of solving this. We know we're going to set it equal to 0. I would probably factor out a 40 pi r minus 8 pi r. Oops, sorry, I factored out the pi. AR to the negative 2. We have now seen a few problems where the constant on the outside, so even though 40 pi, it's not obviously a constant, you have to remember that pi is a number, so 40 pi, this is not going to influence our zeros. So I'm really just focusing on this equation here. And instead, so now instead of 8r to the negative 2, I'd probably bump that back down, so 8 over r squared. So if I solve this, I would probably move the 8 over r squared to the other side. And then I would clear the fraction by multiplying both sides by r squared. And r is the cube root of 8, which is a very nice number. It happens to be 2. Now we have a solution to work with. Let's look back and see what they're asking us for. Find the radius r and height h. We have the radius is 2. If the radius is 2 and we knew way back here that the height was 20 over r squared, r is 2, h is 20 over 4 for r squared, so h is going to be 5. And let's look at our units. Everything in the problem is done in meters, so I would say 2 meters and 5 meters.